Now we'll talk about probability distributions and question 21. Here we have a random variable x satisfying the negative binomial distribution with p equals 0.6 and r equals 4. This is said to measure the number of independent trials, each with probability of success p equals 0.6, that end in successes before the fourth failure. So here's the deal. Imagine us flipping a coin, and imagine that the coin is weighted so that it comes up heads with the probability 0.6, and we'll call flipping a head success. And we're going to flip this coin again and again until we've achieved 4 failures, 4 tails. And once we flip the 4th tail, we'll add up the number of heads that we've flipped, and that's the value of the random variable. So our goal in this question is to find the mean and standard deviation of x, mostly by looking it up online. This can be a pretty confusing kind of thing to do, though. If you look on the Wikipedia page for the negative binomial distribution, for example, they start by describing the negative binomial distribution in a different way than we do here on the center kind of pane, but then they say different texts adopt slightly different definitions, and then finally down below they start giving a bunch of parameters, and in these parameters you can see that they're actually talking about the same thing we are. The support, which means the possible values that the random variable is taking, includes 0, 1, 2, 3, etc., the number of possible successes that you could have. And so that suggests that we're flipping until R failures, and P is the success probability of each experiment. And so this is consistent with what we read in the question. And then in particular, you can see here that the mean of this random variable is p times r over 1 minus p. All right, so that's the mean. And they don't have the standard deviation here, but they do have a formula for the variance, p times r over 1 minus p squared. And remember that the variance is the square of the standard deviation, and so you could just take the square root of this value and get the standard deviation. So let's return to our code, and the negative binomial mean is p times r divided by 1 minus p, and the standard deviation was p times r divided by 1 minus p raised to the 2nd power. And that's the variance, but now we want to take the square root of that in order to get the standard deviation. And then finally, we should try to compute the negative binomial probability. And for this, the formula that's given for the cumulative density function is not very helpful. So here I'm going to switch over and use the SciPy stats commands. So let's try that. And for that, we're going to import from scipy.stats, we're going to import the neg bin, I think it's neg binom. Let's check. Let's check here. Let's just do a quick web search. Negative binomial distribution. Sorry about that. Distribution in Python. And here it's called n-binom. Let's check that out. What we want to do is just read carefully what this is. It's describing a sequence repeated until a predefined non-random number of successes occurs. Okay, so again, they've flipped the successes and failures, and the probability mass function for the number of failures is given by this. And so n here, I believe, is the number of things that have to happen before you stop the flipping, and p is the probability of a single instance of these things that have to happen before you stop the experiment. And in our case, those things we called failures, and they had probability 0.4, and here they're calling them successes. So we have to be a bit careful about that. So they're calling these parameters n instead of r, and p, we're using 1 minus our p. So it's a bit complicated, but it's n binom, and then we want n binom dot CDF, and I'll explain that in a moment. We want k equals 3, and we want n equals 4, and p equals 0.4. So here, as I explained before, the p that they want is associated with the probability of flipping an event that would that's one of the things that will stop the coin flipping, and n is the number of coin flips that have to happen for of a certain type for you to stop the experiment. And what we're doing here is we're using the cumulative density function to calculate the probability that your random variable takes value 3 or less. That's what cumulative density function does for us. And then at the end, we want to be able, hopefully, to see all of these things. Neg-bin mean, neg-bin standard, and neg-bin prob. And here we see that the mean is essentially 6, the standard deviation is 3.87, and the probability of having 3 or fewer heads, in our case, before getting the fourth tail is 0.289, about 29%.